Yes, Ritesh. Let's start discussion on the very hot topic and the new technology and the most important topic, that is the future of financial risks with the help of quantum computing roles in next generation modeling. So what is the future of the financial risks and how it look like with using the quantum computing role in next generation modeling? So let's discuss on this topic. But before, if you learn to the new technologies or the new concepts or how the future will look like, what thing you need to learn or what thing you need to unlearn, if you want that level of understanding, and if you know to get the higher salary in the market, so please like and subscribe my channel so you can think beyond the beyond the your limits after watching my video. So let's start discussion on this topic. So, the first one is the core challenges in financial risk modeling. So, the current modeling or in the classical computing techniques, what are the challenges that financial institutions or the bank faces in the current financial risk modeling? So, to understand and the quantifying the uncertainty, there is an huge uncertainty. So, the financial risk is measure of the uncertainty. Basically, the Monte Carlo simulations or the price of or the portfolio valuation or the risks in the fraudulent, so uncertain, we can't predict. So and to accurately modeling is require analysis and vast number of variable at the scenarios. So we need to conduct a huge number of scenarios or the vast number of variables, or to n number of features we need to fit. But the classical technique are not sufficient to work on that the huge variables or the use scenarios. So, and then the computational barrier. The classical computer are face a course of dimensionality. It's and the curse of dimensionality. It's and the huge challenges in the classical computer is a curse of dimensionality. When the number of variable grows increase the limit and scale the complexity of the model, and it will the time consuming, and the accuracy are result accuracy in the result will get reduced, and it will take the hours and the day to get the output from that result. And it is and also the chance the to get the inaccuracy in that result. So that's why the quantum computing will play huge role in this area. So the key problems in the today's, first one is a Monte Carlo simulation, suboptimal portfolio optimization and inefficiency in trace testing. While we are generating the random scenarios or the random models with using the Monte Carlo simulation, so we are facing we are working on the task like creating the derivative pricing and to define the value at risk calculation and simulating can takes hours and even day. So we doing these performance these activities and to predict portfolio value, so it will take huge hours and the even a days and some optimum portfolio optimization. So while we are finding the ideal mix of asset is a complex combination problem that is often too difficult to solve the perfectly and classical hardware. So while we are optimizing the portfolio, so they suppose the thousands of the underlying asset, if we consider the mutual fund portfolio or the bank portfolio, it contain the n number of the assets in that portfolio. So we need to optimize this portfolio to gain the the higher return with the minimum risk. So the classical computer are not able to sufficient to give the optimum way of portfolio. So that's why we are moving to the quantum computing and the inefficiency the trace testing. So while we are doing the simulating with the millions or the trillions of extreme market scenario to prepare the critical is crisis is computationally intensive. So we need while we are doing to the trace testing, so we take the historical data or it is, and the population data is huge population data, and there million and trillion of the records and the crores of the customers in that system, and we apply on the system while doing the trace testing, and it will time consuming and require huge times, and it is the classical computer are not sufficient or inefficient to do such trace testing. So that's why we are these are the challenges we are facing in the financial risk with the classical physical computing. So let's discuss on the how the quantum computing changes the game, what how they are able to change the game. So they are beyond the bits and bytes, bits and bytes. So quantum computers are used qubits. There is they work on the qubits which can exist in a state of the superposition and representing both the 0 and 1 simultaneously, and they are working the 0 and 1 and the both the simultaneously. So that is the benefits of, and it is at the beyond the bits and the bytes. So let's discussion on the second point, the power of superposition and entanglements. So we will elaborate, or we will use the power of superposition while implementing the quantum computing, and this is allow the quantum computers to process vast amount of data in parallel and use number of data, and what the use of velocity of data we will perform in the parallel and exploring an exponentially large number of possible at once, and we are working to get the fast data from the population data. So these are the benefits, and we are combining the different data sources, and to extract the data from all these sources is it is at the huge speed and the quantum supremacy and advantage. Uh, this is the point at which the quantum computer can solve a specific problem that is a practically impossible for the faster supercomputer and to solve is a reasonable amount of time. So that is the important, these are the huge problem in the supercomputer or the current computer system. So that's take the advantage from the quantum computing and to increase the speed of working, and it is at the cloud based solution. Okay, promise the quantum computing offer a quadratic or even exponentially speed up for the specific type of problem that are prevalent in the financial risks, and that will increase to do the Monte Carlo simulation, to portfolio optimization, to do the derivative valuation, to do the cryptocurrency accuracy valuation, to do the forensic, or to work in the forex market, and to do the valuation of the commodities. So that's the benefits of the quantum computing. So let's move on the next slide. That is the key application for financial risk modeling by using the quantum computing. So what are the application one where we are implementing the quantum computing to get the solution in the fast way? So first one is a quantum Monte Carlo simulations. So we are doing the using the quantum techniques or the quantum methods to do the Monte Carlo simulation, and to predict the accuracy in the price of the assets, or the, to price of the derivative or to forex valuation, or to use the Monte Carlo simulation to predict the future price of the portfolio while doing the quantum computing. So the quantum Monte Carlo algorithm, it's particularly using the technique called the aptitude estimation. So these are the aptitude estimation is a quantum computing technique that we can use to do the Monte Carlo simulation, and it can provide the quadratic speed over the classical method, and it will enhance the accuracy, and this is cloud reduce the calculation time for derivative pricing and war for the hours to minutes, and we are able it we require the hours and they to do such calculation, but with the quantum Monte Carlo simulation we are able to do such things in the minutes. And the quantum optimization algorithm, these algorithms are ideal for finding optimum solution from huge set of possible, and the huge sets of scenarios or huge set of outcomes we get the optimum algorithm or optimize the things, and this is the perfect fit for the complex portfolio optimization, and the portfolio views contain the huge underlying assets and asset allocation and the liquidity management. So we can able to do the liquidity, and how we can easily convert the different kinds of asset into the cash, and that will help from the quantum computing, and we identify such portfolio by using the quantum techniques. And then let's move on the quantum machine learning. So machine learning we do also using the quantum techniques. So quantum supervised learning, quantum unsupervised learning, quantum deep learning, quantum semi supervised learning, these are are the techniques are upcoming technique, and that will increase the speed of your system or the software. And then the quantum machine learning algorithm can analyze the massive and huge dimensional data set to detect the subtitle and the patterns. And guys, we are facing the challenges in the machine learning. There are the huge amount of data we need to spread and the split the data. And we know before train the model, before test the model, we need to feed the data to that model. And we have the limitation, or we need to feed the limited data, because that's not the quantum data. If we get the quantum computing system, so we feed the huge amount of data, and to do the principal component analysis with the quantum computing, and then the accuracy or the efficiency of the softwares will get increased with the machine learning techniques, and the enhance the fraud detection, so identifying the anomalies and the transaction pattern in the real time. So while if we are implementing the quantum computing techniques in the system, so we will do the real time analysis in the transaction monitoring system, or the sanction screening system, or the name screening system. So you might be the future will look like, well, we are, you are currently adding some beneficiary in your bank account, and the bank will allow you to do the 5,000 transaction within the 5 minutes, and then the 50,000 transaction for the 24 hours. And then you can do the 1 lakhs or 2 lakh transaction for that beneficiary. So such kind of thing will never in the future, if they are implementing the quantum techniques. So with the quantum technique, they can immediately do the sanction screening or the name screening of that customer, and identify the risk score of that customer, and if it is at the genuine transaction, and if they found the system found it is not the suspicious activity, they immediately allow you to do the transactions of 1 lakhs or 2 lakhs, whatever the amount at that time they are the optimized. So that's are the benefits, and enhance the fraudulent things by implementing the quantum computing, and improve the credit score definitely. So we require huge number of parameters or a huge number of fields to calculate the credit score. And there is the in the classical computer technique and the current methodology might be not considered some parameters or the some points while calculating the credit score, and they are the optimum, not level of that much level of optimum has the quantum computing to analyze the broader range of the variables for the more accurate and the risk assessment. So these are the benefits or that will be used in the quantum computing techniques. So let's move on the next slide. That is a deep dive into case studies and the example of the quantum computing, where we use the quantum computing techniques. So let's discuss on the derivative pricing, the portfolio optimization, and the trace testing, where we will use huge amount of the quantum computing in futures, and the future will be the quantum computing. So classical or the derivative pricing, so for the complex and part dependent options, so options are the part dependent. We don't know what will be happen in the future, and it is an uncertain event, like the Asian option, Bermudian option, exotic options. So the classical Monte Carlo simulation might require the billions of samples or the trillion of samples to do the optimum derivative value. So the quantum computer could achieve the same accuracy with only the thousands or the iteration way. So it requires the minimum number of iteration technique to get the accuracy of the classical computer technique, which require the million of the samples be able to thousands of the observation by using the quantum technique. So that's the helpful for to do the derivative pricing, equity pricing, or also to do the forex analysis or the forex methodologies. So these we use. And then the portfolio optimization. So imagine, let's consider imagine a portfolio with the hundreds of assets or the thousands of assets, and it is finding the best combination of assets to maximize the return for the given level of risk. It is a problem to grow the exponentially in difficult, and the quantum annular from the companies like B Wave could solve this much more efficient than the more classical problem, and it will give you the optimum value, and it will give you the point or give you the portfolios or the optimum portfolio that will provide you the maximum return or the higher return with the minimum level of the risk of the different assets concentrations in that portfolio. So this will increase the efficiency, this will increase the or the optimize your the portfolio. And then the stress testing, so simulate the thousands of interconnected market variable and their potential collapse in the fraction of time. It's allowing the bank to prepare unforeseen the financial risks and to do the stress testing with a high level, and uh, to do the modeling or the modeling analysis or the modeling optimizations or the modeling validation with using the stress testing to feed the data and to generate the output result from that model. So these are the help from the quantum computing we can take to update the current systems. So let's move on the next slide. That is the current state in the path to adoption. So what are the current state of the quantum computing and how much time or what are the paths to adoption the quantum computing? So current state in the noisy intermediate scale quantum. So NISQ era of the quantum computing. In this era we are working. So we are currently in the NISQ era. So current quantum computer are still small and prone to errors, and it has the errors and limiting their practical use of the large scale financial problem. And it has the some problems to work on this era. So there are the futures era we need to work on that and understand. So hybrid solution, immediate future involve hybrid solution. So we need to work on the hybrid model where the quantum or the classical algorithm will work. So we are work on the both the models, quantum and the classicals, and where the most computationally difficult part of the problem are affordable in the quantum processor, while the classical computer handles the rest. The rest. So there we will implement the use or the small chunk of the quantum things in the current computers, and it is and the futures and the building the quantum workflow. It's and the use starts to building the quantum curve workflow and uh, to give the the workshops or the knowledge related to the quantum or the conduct the seminars for the employees. A major challenge is a skill gap. The financial institution need to hire and train the new generation of quantum quants or the quantum team members, and who is understand both the financial and the quantum mechanism, and who work on the the quantum physics mechanism or the financial engineering mechanism, or they can understand the 360-degree way level of understanding to the financial engineering, quantum physics, and they can quantum mechanism or the AIML techniques or new technologies. So these kind of the skill workforce is that level of skill gaps in the current market. So we need to identify to fulfill these gaps and to hire such peoples. And the key players and the early adopters, the it is and the major financial institutions in that the computing things only. So there are the huge financial institution need to adopt the quantum computing techniques, like JP Morgan Chase, Goldman Sachs, and HSBC are already investing in the dedicated quantum research team, and they are hire the quantum research team, and they working on that things and the partnership with the quantum computing companies, and they work on the quantum computing to adopt the new skills and the new era of the quantum computing. And they have already start working on creating or to investing huge amount of funds in the quantum computing team. So let's move on the next slide. That is the challenges and strategic consideration. So these are the what are the challenges and what need to the consideration in the strategic consideration in the quantum computing. So first challenge is the data security threat. So the quantum computing work on the different algorithms or the different logic, and it is the whole of the different ball game. So the classical computer the algorithms or the techniques are not fit for the quantum computing. So there is a huge chance to get the data the data stolen. So we need to work on the data security to trade from these data. So quantum computer use algorithm like sure cloud one day break current cryptography standard, and such as RAC financial institution must transit transactions to the post quantum cryptography, which we call the PQC, and they adopt the post quantum cryptography and to save or and to make sure their data will be secure and not can be stolen by the criminals. And the quantum model validation. So to do the validation of the quantum models is the very the time consuming and the processing. So it is and the crucial for develop a new methods to validating and editing the models built with the quantum algorithm to ensure the transparency and the compliance with the regulation. So whenever we build the model or we create the model by using the quantum technique, so it is and the challenge to test that model or to validate that model, to do the trace testing or the scenario analysis, and to do the back testing on that model with using the quantum techniques. It is and the very challenging things to validate such model. And the scalability and the cost of building and maintain the quantum computers is immense and require the huge cost. And it is and the cloud based solution, or it require the cloud based assets like the IBM quantum AWS bracket is a key enable for widespread adoption, and it is and the new technologies. So let's move on the next slide, that is the timeline and the future outlook. So what are the time it required to adopt such things, and how the future outlook will look like. So near terms, the 2 to 5 years will focus on hybrid algorithm and small scale proofs of concepts, and early quantum advantage may demonstrate for the specific niche problems. And we work on the small scale of the quantum things, and we creating the computers. They have the work on the hybrid. It is a quantum things and the classical things. And then the comes of the midterms, after the 5 to 10 years, as a quantum computers become a more powerful and the stable in the market, and we could see wider adoption of the quantum Monte Carlo simulation and the portfolio optimization technique are work on the quantum technique, and we are able to optimize portfolio by using the quantum techniques. And use value risk calculation will work on the quantum techniques, and we adopt the quantum methodology. And long term, after 10 plus years, what will happen? The large scale and the fault tolerant quantum computers become the available in the market, and we everyone can buy the quantum computer or work on the quantum computer. And there is add, get the huge speed of the quantum computer, and they may fundamentally change the financial landscape and enabling the real time ultra precise risk analysis and the dynamic arbitrage. So everyone work on the quantum computer. So let's move on the next slide, that is the conclusion and the new era of financial risk management. So this is at the last slide. So quantum computing is not just a distant fantasy. It is more on that. It is a technology that is rapidly maturing and will soon transfer the financial risk management. And the financial the institution like the financial regulators or the financial compliance team will enforce the banks or the financial institution to use the quantum computing and to give to secure their the financial system. And the first move in this space stand again the significant competitive advantage, and through the more specific models and faster decision making and the deeper understanding of market dynamics and the market things. And the future of the financial risk is not just about the faster computer, but it is about a fundamentally new way of looking and solving the industry most complex problem. And the quantum computing will help the bank or the financial institutions to solve their the complex and use the problem with using the quantum computing technique, and improve the speed and to accuracy or the optimization in their the solution. So these are the new way of looking the quantum computing. And guys, it is definitely the future of the quantum computing. So that's end of this presentation. If you like my efforts, and if you like my the video content or the content on which I am going to teach. So please like and subscribe my channel, so that will motivate me to create more such videos for you. And if you need to understand more about the quantum computing, how the future will look like, and what are the roles in the quantum industry or the quantum era, so I will help you on that point. So please like and subscribe my channel, so you will be ready for the industry, and you will get the huge salary in this era. So thank you so much guys, once again thanks.